Hello, this is Lesson 4, Year 7, Solids, Liquids and Gases. I forgot to include this video on condensing last time. Remember, condensing is when steam or gas turns back into a liquid.
So now we're on freezing, melting, boiling, condensing and subliming, which is on the next page. I've just got a beaker of hot water here and I've got a watch glass. I'm holding the watch glass above the beaker of hot water and you should be able to see condensation on the bottom of that watch glass.
Right, we move on to the main investigation in this booklet, Frosty the Snowman. We've got Ben Snowman. He is naked, no dress on. And Ben thinks the naked snowman will take longer to melt, whereas Liz's snowman is clothed, it's dressed. Liz thinks that the clothed snowman will take longer to melt. Which one is correct, Ben or Liz? And why do you think that? So complete this page. Who do you support, Ben or Liz? And why do you think that? This page we can't do, so don't worry about it. And then how are we going to carry out a science investigation? Well, we're going to take a couple of ice cubes. One we will put a dress onto, a piece of clothing as it were. The other ice cube will be naked, no dress, no clothing. And then we're going to see how quickly they melt. Have a look at this video. So the first thing that we need to do is write down our apparatus or equipment list. We have on the left hand side a stopwatch, a measuring cylinder, a funnel, a piece of clothing and 2 ice cubes. You will be mentioning all of these bits of equipment in the method. What's the independent, dependent and control variables? The answers are at the bottom of the page in red. You have to put the correct answers onto the correct dotted line. And then a method. Try and use a variety of time connectives. Don't forget your capital letters and start. And obviously use full stops at the end. I'll give you a flavour of the method, okay? Place a funnel into an empty measuring cylinder. Then take a ice cube with no clothes on and place into the funnel. Start the stopwatch. After every minute for 10 minutes, take a measurement of the volume of water that has melted from the ice cube and collected in the measuring cylinder. Repeat this experiment with an ice cube that is covered in a piece of clothing. There's a very brief method. I'm sure you can come up with one as well. Now, we've got a results table here. In this column here, this one, I'm trying to colour it in at the moment, but it won't have it. This left-hand column, that is going to be your time in minutes. Obviously, I've only written in 0 and 10. You need to put in 1, 2, 3, 4, 5, all the way down to 10. The middle column is the volume of water that was collected in centimetres cubed, That is for the dressed ice cube. The final column is the volume of water collected in centimetres cubed, and that will be for the naked ice cube. Remember, the times involved are from 0 to 10 minutes, and the largest volume of water collected is 3 centimetres cubed. That's the biggest value there. Using these results, you should be able to draw a graph. The horizontal axis will be time in minutes, and that goes from 0 to 10. The vertical axis will be the volume of water collected, and the maximum value there is 3 centimetres cubed. I'm going to give you a little hint. You are going to generate a line graph with 2 lines. The first line will be for the ice cube with no clothes, and the second line will be an ice cube that is fully clothed. So you'll actually have 2 lines on this line graph. Now, finally, what was your conclusion? Look at your results and just say what you found out. Now, why did this happen? Well, you should have found that the ice cube with a clothing round it, an insulator, it was insulated, melted the slowest. And that is because the insulator around the ice cube helps to prevent heat waves from outside reaching the ice cube and melting it. It's acting as an insulator. There's the science there. The clothing is acting as an insulator. It's keeping the cold ice cube colder for longer. Anyway, that's the end of this lesson. Thank you.